Hi, welcome you all. I'm sure that this is the last session of the day, and you would have woke up early, traveled, tired, everything. So we'll keep as simple as possible and as engaging as possible. This is a session called Azure for AWS Architects. The main reason why we put this together is because a lot of people, whenever we go and talk to customers, we notice that a lot of skilled people on the AWS, and they struggle to map it back to Azure. So we thought that putting a mapping together so that it will make your life easier to understand your learning curve. So that's the major reason that we put this together. And I'm Raja, Cloud Solution Architect. I work with the enterprise customers to walk them through on the whole journey of moving to the cloud. Either it could be competitor cloud or it could be on-prem to Azure cloud. So that's my job.
So Andrew Cobb, I'm a technical pre-sales specialist in Azure. So I spend a lot of my life with customers, often with the first time they've seen Azure, and in many cases the customers are already familiar with Amazon. So a lot of it is putting Azure concepts into Amazon terminology, or sometimes on-premise VMware Hyper-V terminology, so that things align and things click mentally. And that's how we're going to run through today.
Okay. And the purpose of this session is mainly to understand the differences, or what is called map the features. For example, you look at the storage in AWS, what is it in Azure, and how we are comparing that each other, or what is called a very major high-level differences. So this session is mainly not to go in detail or to prove which is good, which is not good, feature by feature. That is not the intention of this session. This is mainly to enable your learning curve or make your life easier so that you can learn Azure in a very rapid manner with what you know earlier. And if this is what is called the objective of the session, if this is not the expectation, if you are looking for something else, this may not be a right session for you. So just to set the expectation on it. How many of you, just a quick show of hands, familiar with AWS? Almost all. And what about the Azure part of it? Few hands. So I think we'll try to go as what is called make your life easy as possible, and then we will see how much depth that we can go depending on the interest. So feel free to interrupt us, throw the question along the way. So we have divided this into multiple sections: storage, compute, networking, security, what is called the analytics, etc., etc. So we'll cover section by section. Once again, as I said, that not a comparison. This is purely to map your skills and understand learning, what is called make your learning curve much easier to move forward. So storage side, we have what is called persistent object storage, archival storage, storage extension. So in AWS, it is S3 and EBS. What is it on Azure? Anybody? Exactly. So we have what is called storage, Azure storage. In AWS scenario, it is S3 and what is called elastic block store. In our case, it is what is called the blob store. Blob store again divides into two, which is page blob, block blob. Then we have tables as a storage. We have queue as a storage. We have something called files as well. So it is a little bit more elaborate, and it serves the different purposes of it. So S3, EBS, immediately think about Azure storage. And Azure storage, we divide into multiples, which is block and page blobs. Both do different purposes. Then table, queue, files. Next is the what is called the persistent storage, persistent archival storage. AWS has something called infrequent access storage. That means data that you don't access that frequently, put it there, you pay lesser for that storage. And then Glacier, what is on Azure side? Anybody? Quick. So we have something called cool storage, something called archival storage. How many of you heard about it? You see a tiny star, that means that the feature is in the preview. So it is coming soon, it's not there yet. So if it is in a public preview, you should be able to go back and try. Not suitable for production workloads. And then when it is GA, you move to the production. So cool storage and archival storage is something coming and not there right now. So timeline to be confirmed. We are working on it. You should see soon on that. So that is a negative point. So plus and minus, we try to give you very high level where we win, where we lose, etc. Next is the cloud storage extension. How many of you heard about cloud storage extension and storage gateway? Good, few hands. So basically what happens is we have almost infinite capacity when it comes to the storage on the cloud. On-prem, you always run out of the storage. How do you extend your storage to the cloud? So that's the storage gateway. Basically, AWS storage gateway is your virtual machine that you deploy on your premise, and then it extends the S3 so that you can make use of that infinite storage on the cloud. On Microsoft, we have something called Store Simple. It is a hardware device, and then appliance. Just bring it, plug it in, and then starts working, and then complete Azure blob storage is in your hands after that. So what is the plus and minus? Storage gateway is a virtual machine. You get your own hardware. You download the virtual machine from Amazon, run it, you extend your storage, whereas ours is what is called the storage with spinning media, storage with solid state drive. So there is a tiered storage there, and you can declare that as an iSCSI. You can what is called do a snapshot backup to the Azure, as well as on Azure you have something called a Store Simple virtual appliance. So whatever you store it on Azure Blob, you can use that appliance to see that as the Store Simple on the cloud. So for example, if you have deployed a virtual machine on the cloud, you want to access the contents from there, you can use the Store Simple virtual appliance to do that as well. So plus and minus, when it comes to the appliance, some people say it is good. Some people say, no, I will lose my flexibility. I don't like the appliance. I want all the flexibility that I can configure, play, change, whatever I want. Whereas some people look at it positive, some people look at it negative. So that's the storage. Any questions before we move on to the, yep?
Is this slide deck available after the session?
So okay, can you repeat the question?
Are we able to access this slide deck?
Yeah, that's right. The question is, are we able to access the slide deck after the session? On the Ignite, what is called all the slides, not only just this session, every session along with the recording will be uploaded.
Just while Raja's getting his demos ready, the key distinction between S3 EBS and the Amazon storage and Azure storage is Azure you have storage. You can provision a storage account, and that one storage account will simultaneously do virtual machines and blob storage and tables and queues and a file share. So there's just storage. The only thing you really choose is whether you want SSD or spinning disk, and whether that storage is replicated geographically or just within one data center. So really, you just provision storage and use it.
Okay, this is the Azure Management Portal. So whatever the storage accounts that you create is listed here. You can go ahead and then what is called create a new storage, and inside the storage, you go ahead and then create your what is called the containers. And Andrew's giving it what is called analogy that the containers are something like your LANs. And the storage accounts, you can create multiple storage accounts per subscription and then extend it to the either the resources on the cloud or on-prem. So this is the management portal, and you have a lot of third-party tools. On the Codeplex, you have something called Storage Explorer, which you can also download, and there are a lot of third-party tools. So I'm using a tool called Cerebrata. So once you what is called key in the credentials for your subscription, all the storage accounts are exposed here, and then I can go ahead, expand it. Tables, we just spoke about. You have queues, you have blob containers, and all of this. So in this case, I want to explore my tables. So I have few tables. So these tables are basically what is called the audit logs or monitoring and alerts and events produced by various resources. They are dumped as the tables. So just to show you an example, you can choose any one of them. Simply double click, So this is a storage, like a table, what is called without any compute attached to it. Okay, so you can look at it. It's a key value pair. You can see the timestamp, and this is one of the performance counter. So you can see which deployment ID, which role it is, what is the counter value, etc., etc. So Excel has a tool called Power Query. Power Query can connect to this, download the data, and do all kind of pivoting on top of it. Similarly, Visual Studio also has a tool, what is called this Azure Explorer, which can connect to the tables, and then you can make use of the data that is stored on the table. Next is the Azure Files. Azure Files, as I mentioned earlier, basically storage you have created, and then you have exposed that like a file share. Imagine that you create the storage account, create a what is called the share from all your virtual machines on the cloud or on-prem or from your own PC. You can see that like any other NTFS share. So in this case, for example, I have a storage account called Southeast Asia. Let me get in there. So this is a storage account. So in this storage account, I created something called Azure Files. So I'm going to, let me run my zoom it so that I can zoom it. Give me a second. So if you look at it, I'm issuing a simple net use, my storage account name, file co windows.net. So this is exposed on the cloud when you create the storage account. And then my what is called the share name, followed by storage account and the credentials to connect to that storage account. And then if you notice, I'm what is called mapping it to a drive called Z drive. So let me execute this. So the command completed successfully. If you switch to my what is called the Windows Explorer, I see that as a drive, and whatever the contents there, I can go ahead and then treat that like any other Windows file share. So the complete Azure storage, per storage account, we are talking about 500 terabytes of storage, and you can create multiple storage accounts. So everything is in your reach within your simple Windows Explorer. So that's the power of storage that you are extending. So that's Azure Files. And VHDs, in our case, simply the difference between us and Amazon is you create a EBS volume that is like a kind of black box. You have to attach it to any existing, or what's called any virtual machine in order to access the contents. For example, the machine is not booting, or you want to do an offline patching. You want to pick up a single file from a VHD, it is a little bit of a headache. So in Microsoft scenario, it is like any other on-prem virtualization. For example, you are running a VMware or Hyper-V, you have a VMDK file or VHD file on-prem. If you want to restore a single file, all you need to do is pick up the VHD. For some reason it is not booting, for example, pick up the VHD, mount it on the any other running virtual machine, see that as a drive, pick up a single file, or do whatever maintenance that you want. So the same concept in the cloud. On the storage account, every what is called the disk that you attach it to the virtual machine is presented as a VHD. You can simply go ahead and then mount it to any other virtual machine that is running and do whatever you want without spinning the VM. Okay, so back to.
Okay, once you've got your storage set up, you typically have to create some networks. And you do that generally before you start building virtual machines. In AWS, generally you're building a VPC. and you create your VPC, that holds all the subnets and other information, the address ranges, and you deploy your virtual machines. The equivalent to a VPC in Azure is a VNet, or a virtual network. And in most ways, the concepts are almost identical. An Azure VNet consists of one or more CIDR address ranges. Typically, if you're doing an extension of an on-premise environment, that's going to be a 10 network or 172, but it can be a public IP address range if that's what you need to use. So one or more CIDR address ranges. Each of those CIDR address ranges is then carved up by you into one or more subnets, /24s, /28s, whatever makes sense. Those subnets can then have firewall rules controlling what goes between them. I can define custom routing rules and custom routers, and packet inspection devices, SQL injection attack prevention tools, and so on, if I need to. I control the DNS settings that get applied to the virtual machines on that subnet and on that VNet. And the VNet also defines how, if at all, it's connected back to on-premise, whether that's via a VPN or via a direct connection of some sort. So the VPC and the VNet, very similar in concepts. The key distinction is outbound traffic to the internet or inbound traffic from the internet. So the NATing, either outbound or inbound to reverse proxy, you don't need to provision additional VMs. So the outbound proxy and the inbound reverse proxy is just a function of the VNet. No additional VMs are required. Thank you. So I'm going to do these one at a time. So I'm looking at the new portal. There's a couple of portals we'll flick back and forward today. I've got 5 VNets here. A single VNet can contain thousands of machines and a whole bunch of addressing rules. So for many organizations, they'll only need one VNet. So this particular VNet here, if I have a look at it, so the address space being used by this, 10.1, so it's class B. I've defined that, create that as required. I've then carved that class B up into 5, 6 subnets, most of them /24s and a /28 or something. Front, mid-tier, back-end, and so on. The default behavior when I create all those subnets is they'll just route. Standard layer 3 routing, no firewalls, they'll just route between them, a lot like you did if you did on-prem. If I want to, I can create what's called a network security group, which is basically a list of ACLs. And you see here for the database subnet, I've applied a network security group, which is basically saying that in this case, the mid-tier can talk to the database tier inbound on port 1433 for SQL, and that's it. Similarly, I have a DMZ subnet that I'll use to host internet-facing web servers and so on. It's going to have a Barracuda in it, and it'll have additional firewall rules on as required. So if I need to place additional firewalls, I pick a network security group from the list of ones I've created earlier, hit save, and off I go. A VNet will also typically have a set of DNS servers. And as you can see there, you can choose between the Azure provided DNS servers, which will basically resolve the internet and anything on that VNet, or you can create custom DNS servers. So if you're doing an extension of an on-premise environment, those DNS servers may be your Active Directory domain controllers, if they're your DNS servers, or your Linux bind servers, or whatever you're using for DNS. You can point that VNet at your existing DNS servers, whether they're on-prem or copies of those DNS servers sitting in Azure. So fundamentally, a virtual VNet and a VPC, very similar concepts, and they're used in very similar ways. I go back to 5, don't I? 5 minutes. Okay. When you first start out in Amazon or Azure, typically you're connecting over the internet, your remote desktop in or SSH over the internet, out your proxy, over the internet. Once you start doing lots of stuff and you want to start moving corporate servers, you'll typically establish a VPN, or when you go one step further, an AWS Direct Connect into AWS. The equivalent Direct Connect in Azure is called ExpressRoute. Once again, a lot of the concepts apply. There's a couple of ways of getting ExpressRoute, but most commonly you're either talking to Telstra to get another leg hung off your MPLS network, or you're talking to someone like an Equinix, NextDC, Megaport, someone like that. The links from those sort of data centers and cloud exchanges into Azure already in place. You get a link into, say, Equinix, and they plug the two together. So the basic concepts still apply. You can get up to 10 gig per second via that. It's a private network. You're not subject to normal internet latency, but the same concepts apply. The key difference is that on the Azure side, you get 2 ports from, say, Equinix through to Azure when it's configured rather than a single one. So you're getting hardware and cable and fault tolerance all the way through without having to do anything extra to provision it. Similar concepts apply. When I establish a express route, the express route is sort of the layer 3 or the physical connection, and then I'll establish anywhere up to 3 BGP sessions over that. The private one connects my on-premise, say 10 network, to a 10 or 172 VNet I've built in Azure. So it's an extension of my data center for private networking. The public one down the middle is to connect to all the other Azure services. So Azure Storage and Azure Database and so on, things we'll look at later on, typically use public IP addresses. And so if you establish that public peering, it means that the IP address ranges of those public services are advertised back down the express route and into your internal route table. So when a workstation or a server needs to access Azure AD or Azure Storage, it resolves the DNS, gets an IP address, and your internal route is routed up the express route rather than out your proxy server. The third one, the Microsoft peering, is fundamentally for Office 365 and shortly CRM Online. So it's a third BGP, and once again, all the IP addresses that relate to 365 are advertised down that third peering. Someone sits inside your network and tries to resolve mail.microsoft.com or whatever 365 needs, it'll go up the express route rather than out your proxy server. So if you're using 365, you can get 10 gigabits of dedicated, high performance, secure connectivity through to Office 365 rather than going out your proxy server. It's the same DNS names and the same IP addresses. So when the user then picks up their laptop and goes home, there's no change. Their home router resolves the DNS to the same IP address, it just goes the other way. Similarly, if there's a failure of any sort on that public peering link, it'll flick over and go out your proxy server. So it's very flexible in the way it works. Oops. And the last one is the DNS side of things. So AWS, Route 53. So Route 53 is both the global sort of traffic distribution as well as the DNS services. Azure has similar concepts. I mean, it's two different things. The Traffic Manager, we'll have a look at shortly. Traffic Manager provides the global distribution. I may deploy a website into Melbourne, Sydney, and New York, and Traffic Manager will handle load balancing or failover or nearest user distribution to those websites. And we have a service in preview called Azure DNS, which will enable you to host the actual DNS zone inside Azure as well. The Traffic Manager looks like this. That's not what I wanted. That's not what I wanted either. Where's Traffic Manager? There we go. So I've created a, no, why is that doing that to me? It's still doing that to me. There we go. Because it's flicked on to extend rather than duplicate. There we go. Okay. I've got two websites, one deployed in Melbourne, one deployed in Sydney. Each website scales and has HA capabilities in those respective data centers, and I've deployed an Azure Traffic Manager over the top. So if I go to AC website, whatever the suffix is, I've configured two endpoints, one in Melbourne and one in Sydney, which when I hit that public traffic manager, it will use whatever rules I've defined to work out where to send those on to. There's three ways I can configure the routing rules. Well, not routing, but DNS resolution rules, known as failover, performance, and round robin. So failover at the moment, whichever one's primary at the moment, I think it's Melbourne. All traffic will go to Melbourne unless Melbourne's down, in which case then all traffic will go to Sydney. So the failover mode. The round robin mode is simply that. It's a round robin. You can weight it 80-20, 90-10 if you want, but fundamentally it's a distribution mechanism. The third one, the performance mode, looks at the latency between the requester and where it's going and sends you to the nearest one. So I can have copies of my website in Sydney, New York, and London, you know, all fronted up with a common public DNS name, and as the users travel around the world, they'll be directed to the nearest one. And really, simply by creating a traffic manager and adding the endpoints, that's all I need to do. Yeah, over to you. Yeah.
How do you trigger the failover? What triggers the failover? Can it be manually triggered? Can it be held up? Where does the control point lie?
So what I haven't shown you is, yes, you can manually do it if you've got explicit monitoring of some sort, but normally, because it's generally it's front-ending websites, it will continually poll those websites, or the way you define how to poll those websites, normally simply on 80 or 443. Is the thing up? Is it returning an okay status? If it is, we're good. If it's not, it's down and will fail over. If you want more comprehensive, you need to get a specific return value or something, you may do that with a script and trigger the failover yourself. Gotcha. Oh, no, compute, back to me. Okay, yeah.
I'm not sure if I missed it. Is there an option to send a fail, if there's a failure, to send it to a blob storage or a static website, like you can in Graph3?
To record the failure.
No, to send, if you have a failure on a site,
Yep.
is there an option for it to fail over to a blob storage, like you can in Graph53?
Can you repeat the question? Okay, the question is
Yeah,
like...
yeah. So in this particular case, I happen to be load balancing 2 websites. But in practice, I could load balance pretty much anything. So if I happen to be hosting static content on an Azure blob storage, that's something I could front end if I wanted to. Yes.
Okay, because maybe I'm not understanding properly, but if you have a normal IIS, 2 IIS servers,
Yep.
in one region, the region goes down.
Yep.
In Amazon, AWS, you have the option to actually fail that over to an S3 bucket that's
Yep.
hosting just
Yep.
static files.
Yeah. So I could host, I mean, you saw I had 2 websites there. I could have had a website and static content, for example.
And,
I mean, you probably wouldn't do that not in the in the Azure context, but technically, you don't have to be hosting the websites and it doesn't have to be the same thing in each site.
And a quick clarification as well, S3, you can expose natively as a web, like what is called the HTTP, and you can treat it as a web. We don't have that capability on the blob storage. So you need to go through some other alternate mechanisms to have the regional availability.
We've deployed our storage, we've deployed our network, now we can do some compute. The compute's a bit of an arms race, really. Amazon has EC2, I'm sure you're all familiar with it, standard virtual machines. The equivalent in Azure is virtual machines. It's called nice, simple names. This changes all the time and it could be out of date now. At the time of writing, the Azure G5 was the largest virtual machine available in the public cloud, may have changed. I know Amazon have announced the X1, I think it is. I don't think it's yet available. On the flip side, Azure doesn't currently have virtual machines with GPUs, but we've announced that and they're not far away. So the compute side of things is a bit of an arms race, but a lot of the functionality is available in both. You can build big virtual machines, you can scale them up, you can scale them out, you can have SSD storage, you can have all sorts of things. Second one, if I'm not doing servers, is the desktop side of things. So Amazon has workspaces and AppStream. Our workspaces is fundamentally a full desktop. AppStream is more of a published app. Azure, you can certainly build a full desktop environment if you want, but the as-a-service solution is remote app. So it's a fully managed solution. You basically provide the apps and we take care of the scaling for it, as well as the licensing. The key distinction is the price point. So Azure Remote App starts at about $10 per user per month. I think Workspaces is 25-ish, but I'm happy to be corrected. But on top of that, if an organisation has RDS licenses, for example, and there's a number of other offers available, that $10 per user per month can get a lot lower, like 80% lower in some cases. So for $2 or $3 a month, all licensing included, all hardware included, all compute included, you're getting a published app solution for either your customers or your staff. And the last one related to that is sort of managed compute. So Elastic Beanstalk is the sort of platform as a service offering from Amazon. The equivalent from Azure is called Cloud Services. Now, this is actually the first thing that was released with Azure 6-7 years ago, called web roles and worker roles. The advantage of, or the key distinction is that Azure Cloud Services is a native function of the platform. All the tooling in Visual Studio knows natively how to create these things. We can scale them, we can manage them. The life cycle of them is taken care of. It's really native in the platform. If we go back and have a look on number 6, this time I'll use the other portal. So I can deploy virtual machines in a number of ways. The most common is to deploy a virtual machine from the gallery. So I've got a long list of pre-built virtual machines that Microsoft and our partners maintain the base images for. So base Windows Server of various versions, Windows Server with SQL, BizTalk, and a whole bunch of other things, including Oracle, pre-installed. As we get on further, you'll find a variety of Linuxes, Visual Studio pre-built, a whole variety of Linuxes. We announced a big Red Hat partnership last week. And as we get further down, Barracudas and Riverbeds, and there's a whole bunch of appliances as well. These are just the images that are pre-built, sort of certified and managed by Microsoft and our partners. There's also a marketplace which has thousands more. All of the images from this list are license included. So if I deploy a base Windows Server, no different to Amazon. The hourly rate includes the Windows Server license. If I deploy a SQL Server from this list, or Oracle, the hourly rate includes the SQL license and includes the Oracle license. So the hourly rate is higher, but it includes it. If, on the other hand, I'm migrating something from on-premise and I already own the SQL license, I just want to transfer it, I deploy the base Windows one and migrate the license. Your choice. The break-even point depends on your agreement, but it's roughly 3 years, very roughly, of 24/7. So if I'm building an environment that's going to sit there for 7 years, probably buy the license. If I'm doing a joint venture that's going to last 6 months, rent it by the hour. Your choice. In addition, most organisations will have, I picked the right one, on-premise today, you'll have one or more master images, syspreps for Windows images and so on, your antivirus tools, your configuration, your lockdown. This is the equivalent in Azure. So you'll simply upload your sysprepped images and the equivalent for Linux. They appear here and you can deploy them as normal. So regardless of what I pick from this list, everything else we're about to see looks the same. So let's use the base server image. So the machine needs a name. This is purely a name. It's not the internet-facing name or anything like that. It's just a name. And it needs a size. Whole long list. The list keeps getting longer. But roughly speaking, the A-series machines have spinning disk. The D-series machines have SSD available, and the CPU is about 60% faster. And the G-series machines, which right down the bottom somewhere, big stonking machines up to half a terabyte of RAM, designed for big data warehouses, SAP HANA, very big things that need lots of compute and lots of RAM. They don't come cheap, but if you need that sort of thing, they're available. What I picked from this list is just the starting size. I can come back later and get something different. Needs a username and some passwords. On a Windows machine, this becomes the admin account. On a Linux machine, it's slightly different. It'll be the root account. This screen here can get a bit complicated, which is why we covered network and storage first of all. But fundamentally, do I want this thing to be internet-facing on a private network connected back internally or on a private self-contained network? My choice. This one's going to go public-facing with this name. Where do I want it deployed? I'm going to deploy it back onto this guy I've had earlier. Which subnet on here do I wish to use? That one there, so it'll get the next available IP address on this. Which storage account should I use? And then which ports, if any, to be available from the internet at the point of deployment. So normally it's just RDP. If I've got an express route, i.e. a direct connect in place, I may want nothing available from the internet, and I'll just remove those. Everything that you're seeing Raja and I do now, through portals and typing in passwords and so on, can and often would be automated. Whether it's PowerShell, whether it's scripting, whether it's APIs, whether it's automation tools from Microsoft or others, because at enterprise scale, you typically don't want to be typing in passwords at deployment time. But the portals are useful to understand how things work. This last screen here gives me the option of installing antivirus tools and Puppet and Chef and custom scripts and so on at the point of deployment. So they're going to do its thing. Deploying a virtual machine in Azure is about the slowest thing there is in Azure. It takes about 5 minutes, and that's mainly because there's a 100-odd gig of virtual machine that's being copied, powered up. Sysprep runs mini setup a few times, just like on-premise, and eventually I've got a virtual machine that's up. How have we got for time? We're running low. So, the only other thing I wanted to cover briefly was just the way storage performance works. And I won't demo it, but we can do it later. Each disk you present to an Azure virtual machine, each spinning disk does 500 IOPS. Each SSD disk does up to 5,000 IOPS. So if you've got a workload and you need 3,000 IOPS for database server, you present 6 disks. It's as simple as that. So it's very simple mathematics. How many IOPS you need, divide by 500 or 5,000, and that's how many disks you go. So the big VMs can do up to, I think, 60 or 80,000 IOPS if you're presenting SSD disk. AWS has a different approach generally, which is, I think it's 2 or 3 IOPS per gigabyte. So either way, you can scale your IOPS, but it's done slightly differently. Okay. Remote app. Oh, remote app. Sorry. Thank you. So remote app. So I've created a remote app here. I've published a bunch of apps out of it. I can go and publish more applications and so on. And what I get, depending on the platform I'm on a Windows or a Mac machine, I get a launcher like this. On iOS, Android, and Windows phone, I get native apps. And when I run something, Excel should start up and do its magic. It's going to whinge it's not licensed, but it's simply RDS as a published solution with no management, no licensing costs, and it starts at $10 per month and goes from there. So a remote app is very easy to use, rather than building traditionally a whole bunch of RDS servers and optionally Citrix servers on-premise, licensing them, managing them, building gateways and so on. I spin up a collection, I install the software, and I assign users.
Yep.
Okay.
Thanks, Andrew. Next is the databases. In a AWS scenario, database as a service is covered by a service called RDS, what is called the relational database service, and then on Azure, SQL-DB. On the plus and minus, if you look at it, RDS comes in various flavors: SQL, Oracle, MySQL, and multiples of them. Whereas for Microsoft, naturally, right now, for a PaaS offering, SQL-DB is the only one available. And you may be thinking that Andrew was showing the Oracle. So that is an infrastructure as service. So don't get me wrong. When we talk about databases, infrastructure as service, PaaS, infrastructure as service, install your virtual machine, bring whatever you want that you run on the premise on the Azure. It could be DB2, it could be Oracle, it could be MySQL, it could be anything. Whereas the platform as service, which is a managed service that we offer, is only SQL-DB. And then what is the plus and minus? In our case, we have a very rich geo-replication capabilities. Some of them on a premier tier can go into RTO of 0, almost 0. Why I say almost 0? Because if you deploy the replicas in different geo-regions, one in Sydney, one in US, they need some time to replicate. If they do a synchronous mode, your clients need to be kept waiting. They don't want that to happen. So they go to a less than 5 seconds of RPO with that. So future, what is called the geo-replication is a plus point. And at the same time, when it comes to Microsoft, we are lacking those third-party platform as service offerings. So that is the difference. And what is called the managed caching. For example, if you are running a website or something, you want all the what is called the frequently accessed stuff in the cache. Managed caching. AWS provides Elastic Cache. We have something called Azure Cache. And the difference is AWS offers 2 or 3 different variety of engines like Redis, Memcache, and we offer Redis right now, and Memcache is missing in our scenario. Next is the MPP. How many of you are aware of MPP? What does MPP stand for? Only one in the crowd. MPP is basically massively parallel processing. For example, think of a SQL engine. If it is a single machine, I can scale up. No matter how large I go, I might get stuck at certain scale. For example, 1 terabyte, 100 terabyte on a single machine, I can't load more than that. So that is where MPP engine comes into picture. You can scale out for multiple machines. That means I install 10 different SQL servers. I see them as a single machine, single database, query and consume as a single database. So that's the MPP. Amazon has Redshift. And Redshift is based on Postgres engine, whereas Microsoft, you see a small asterisk there. It is in a preview stage right now. That is called Azure SQL Data Warehouse. So what is the plus point? In Amazon scenario, for example, if I have 100 terabytes of data, I pay X dollars. I'm not going to use it for 10 days or a month. I need to keep paying X dollars. Whereas on Microsoft scenario, it is a pure utility model. You have a scale that you can drag and control how large you want, as well as you can pause it totally. When I pause it, you just pay for the storage, which is very negligible, and you don't pay for the compute. So it's a pure utility model, and what is called much more open for, and it uses the SQL engine. So what is called the advantage is any client tool right now that can connect to SQL should be able to connect to SQL DW. So all the reporting, what is called the development tools, everything is going to work seamlessly. So that is in the preview stage right now. So very quick demo. I just want to show you a couple of things. One is that I have a database that is running on one geographical location. I wanted to show you how easy it is to deploy in another location. If it is a normal SQL server, you need to set up a cluster, always on, and then configure your database. It takes experts like 2-3 days to set it up totally. And if everything is smooth, it is faster. Otherwise, it is going to be challenging. So whereas if you look at this, these are the list of databases. So this one in particular, so if you look at it, right now it is running in, let me start this. Right now it is running in West US, which is here. And I want a replica to be in Singapore, for example. All I need is locate the data centers that is lit up. Based on my subscription, various data centers will appear. So all I need is choose that and then configure my parameters like what size it is, what it is. Come on.
Sorry, quick question for the database service. Do you get a choice in terms of which version of SQL you can use?
If you look at the what is called the system, we have something called V11 and V12. So on the cloud, we have 2 versions. So you get to choose which one you want to deploy. And then with the sufficient notice, the previous versions will be deprecated. And you will be given a choice to, by click of a button, move to a newer version when newer version is available. So the answer is yes, but it follows a different stream when it comes to cloud. Okay, my portal is not coming up.
So while Raja fixes that, a lot of the PaaS service, so if I'm building virtual machines in Amazon or Azure, you have full control over the life cycle of what's on them. With the PaaS services, by and large, they're designed to be evergreen. So the concept of, in SQL Azure, you don't have the concept of SQL 2012 or SQL 2014. It's SQL Azure, and it's always up to date. So, regular monthly patching or whatever needs to be done for security patching and so on just happens. There's no downtime. You don't even know about it. Very occasionally, I think it's only happened once for SQL, we introduce new technology such that to just deploy it would be a breaking change. And when that happens, we deploy it parallel, normally for several years, and you get to choose which one. But regular minor updates that just add new functionality and security patches just happen, and it's evergreen, and there's really only one version, it's SQL Azure.
Yep, so if you notice on the screen there, we have a V11 and V12. Create a V12 server. You say yes and no. So if you say no, it is going to be a previous version, if not V12. So what I'm doing now is on another region, I'm going ahead and then creating a SQL server and declaring that SQL server to be a replica for my machine. So right now, if you notice that it is initializing the deployment, and then it will go ahead and then create. And if you look at the map here, you can see that nice line flowing through. That means that the database currently being replicated. Once it is completed, replication is done, it's online, and then that line, what is called, becomes a continuous line. And then all your changes that you commit in one place will be committing on both the servers. When it is for any reason, either it is a DR drill or the regional data center is gone for any reason, the other one becomes a primary. When both are running, you can configure the secondary replica to be a readable replica. So your ETL, what is called any other reporting, backup, all can run on the secondary machine, relieving your primary machine. So this is a geo replication. This easy it is to bring it up. So next one, what I wanted to show you is the data warehouse. So you can notice here, pricing tier, you see that it's a data warehouse, it says. So this is the data warehouse. So if you look at here, for example, if I want to scale it, you can see here, very simple. All I need to do is to drag this, bring it up. So if I say 2000 DWU, data warehouse unit. In our SQL PaaS, we call it as a DTU, database throughput unit. We don't give you option to choose how many cores, how much memory, how much IOPS, nothing. You just define the DTU, number of transactions that is documented, explained on the cloud, on the web that you can go and read and understand what is a DTU. That is for the database throughput unit for OLTP SQL database. This is a DW, data warehouse. So here it is called DWU. Every 100 DWU is almost like one node is added. So in this case, for example, 20 different nodes. If you upload 1 petabyte of data, multiple nodes attached to the chunk of data, and then they start to process in parallel. When you issue a query, select star from my fact table, all of them are what is called distributed. They do their work, assemble it, give it to the central node, you get the result back. Okay, so that is the beauty of data warehouse. And then depending on the DWU that you choose, you start paying for it. So during the peak hours, you can say that I want 1000 DTU. At 5 o'clock, you can say that I want 100 DTU. Or you can even totally go ahead and then pause it. So you can see here, tiny button pause. That means I have 100 terabytes, I pay for 100 terabytes of storage. I don't pay for any compute. So that's the beauty of it. And then what is called, if you want to develop it, you have a button there to start from Visual Studio straight away. You want to create a view, stored procedure, trigger, whatever you want to do. Or you want to analyze the data that is on the data warehouse. You can simply connect here and then open in a what is called the Power BI and start consuming them. So that is a native integration and capabilities that are extended. Okay, so that is for the databases. Any questions before I switch? Yep, very quiet audience. So I assume that a lot of you are coming from infrastructure background. So analytics side, what do we have? How do we compare against Amazon? Big data. How many of you are familiar with big data? Very few. So basically, for structured data, you look at the data warehouse. For unstructured data, you look at the big data. So big data basically what it does is same concept of data warehouse MPP, master node, slave nodes, multiple slave nodes, or worker node, what many people call in a different terminologies, basically a master and slave, and then you dump the data, split into multiple nodes, they parallelly process, return the result set. So AWS has something called EMR, Elastic Map Reduce. That means that multiple nodes, the data is mapped into multiple nodes, they reduce it into a smaller aggregates, return to a central node, or it's called the master node. Master node crunches gives you the aggregate data. Then they have something called data pipeline. For example, multiple systems, you want to gather the data into a single location for analysis. It's like a ETL tool. So they have something called data pipeline. Then they have something called Kinesis. Kinesis is basically if you have multiple sensors sitting in every part of your business, like manufacturing plant, each and every manufacturing machine, I have a sensor to measure the temperature, to measure the dimension, etc., etc. They poll the data. Kinesis is the guy who receives data from multiple what is called sensors for further processing. So what do we have on Azure side? We have something called HD Insight. It is what is called the flavor of Hortonworks big data that is built on our platform, which is HD Insight. And we have something called Data Factory. Data Factory is basically a cloud-born ETL tool that can connect to your source, get the data, do some transformation, dump it to the target. So that is the Data Factory. Then we have something called Stream Analytics. Stream Analytics is like keeps on looking at the data that is coming from multiple sensors. When any one of them goes beyond my threshold that I set, or data with anomaly, abnormal data, alone is picked up, do some active action on it, notify somebody or trigger something, do something. So Stream Analytics, looking at very what is called rapid manner, all the incoming data, do some action on it when you find some anomaly. And then the what is called the data lake. How many of you heard about data lake announcement? 1, 2, 3, very few. Basically, a data lake is something like our SQL data warehouse you have seen. You dump the data, you pause it, you only pay for the compute. And then you have a scale to slide, how large your processing capability to be. So data lake and what is called the data lake analytics. Data lake is divided into two. One is data lake store, other one is data lake analytics. So same capability. You have a slider in Visual Studio, for example, or in your development tools, you have a parameter. You specify how large the compute to be, dump your data, and then this large computer chunk goes, picks the data, process, gives you the result, shuts down. So the beauty is you only pay for the amount of compute that you use. You don't need to set up a big data cluster, start paying for it, whether you use it or not, and then the management headache and et cetera, et cetera, et cetera. Pure utility model, bring in your data, pay for the storage, only pay for the compute when you use what is called the compute cycles. So that is a data lake, which has two components, as I said. Plus and minus. One is that the native capability. Inside the big data, there are hundreds of components that open source has built for various purposes. So if you look, commonly used is a HBase, Spark, Storm. All these are available part of it on Azure scenario as part of the HD Insight. So if you go into the create, you will see Storm, HBase, and et cetera, et cetera. And what is called the stream analytics. In order for the stream analytics you use, all you need to know is the T-SQL statements. So if you are a developer with the basic SQL knowledge, you should be able to kickstart that immediately. And then on HD Insight scenario, once again, you pay for the storage separately, compute separately. On a EMR scenario, for example, if you bring it down, your data is gone. Or what is called, you need to build it again when you bring up the cluster. In our case, it is separated so that you can bring down your cluster. 1 month, you don't pay for it. Set up a cluster again, latch onto the same storage. It's going to start functioning. Sorry. Next is from predictive analytics part. There is something called machine learning. Once again, machine learning for AWS, it is just gone live. And what is called Microsoft Azure machine learning was there for almost a year now. And plus point is a number of algorithms in order to do the prediction. If you are a data scientist, you know what kind of algorithms are useful. And number of algorithms here are huge. Plus, we have, if you don't find the algorithm that you want to use, you are a, what is called the R language programmer or Python programmer. As a data scientist, you build your algorithms there. Just copy the code, put it here in the Azure machine learning. We take care of the compute. So you develop on-prem using any tools that you are familiar with. Just copy the code in a what is called graphical window that we provide. Paste the code, and then we create a web service, use that algorithm, predict, give you the prediction to you. So that powerful it is. So it is what is called too far, in my opinion, even to compare. Next is Enterprise BI. QuickSight is the new what is called the offering that AWS has announced in the recent reInvent, and I'm yet to see that. When it comes to Microsoft, we have something called Power BI. Power BI did exist for almost a year, and major revamp took place like June, July timeframe, and maybe I'll touch base quickly depending on the time during my demo. So the difference is Office 365 integration. For example, if you have what is called the Excel, our authoring tool for Power BI could be Excel. And then if you have Office 365, it naturally integrates like AD, permission, portal, everything is integrated to Office 365. And rich feature set and data source support. The amount of data sources that we connect is almost enormous. If you don't find any, all you need is ODBC drivers, and then it starts working. Okay, compared to QuickSight, which is details are yet to be known. In fact, when I presented this last round, it was a question mark there. AWS just came back with this. So very quick Power BI that I wanted to show. Yep. So this is the dashboard that we built it. It is building this, if I go through, I think it is another hour-long session, but you will be amazed at how easy it is to use the Excel, connect to the data source, bring it. It's all like a Microsoft Access table, drag and drop, establish the link. How you create an Excel pivot, you create that pivot, dump it there as a dashboard there. Okay, and the beauty that doesn't stop there. For example, I have multiple dashboards here. Right? I wanted to what is called explore the data in a very simple query language like a human. For example, I want tweets. This is a social analytics. Tweets by state. And I get my result out here. And if I want this on a map, because I'm exploring on what is called the geographical data, I can simply say map, comes up. Okay, so all I need to do is I need the data, connect, data is ready. Just give one simple report as a dashboard, good enough. End users go there, start typing their question, whatever the chart they want, they get it. So I said on map, I can simply say as a pie chart, a bar chart, scatter diagram. All of them comes out. And then I can simply use this button and then pin it to the dashboard again. Okay? So whatever you explore, you can put it as a dashboard for other users to consume as well. That powerful it is, and as I said, the SQL data warehouse, SQL database, everything can be integrated. And from the portal, I can simply just by clicking on this, I can create a data warehouse. By clicking that button, I create a new Power BI report ready for me to drag and drop and explore. Okay, that powerful when it comes to the analytics side. And then I'm sure that you guys would have used the Katana. So the natural query that I issued, like tweets by topic by state, I can simply talk to it and then bring up the data in the same canvas. So just go and explore on the internet. You should see some YouTube videos. Basically, you can ask that, what is my sales output for last month for a particular product? So all in your fingertips inside your Katana, for example. So that powerful when it comes to the BI. So let me switch. And as we said that whatever we are talking about, every one of them is like, every one slide or one line we talk about is like a couple of hours topic. So apologize, we are rushing you through. So if you are in depth on it, please review through the catalog of the sessions available and sit through that.
Okay, once you've deployed all this fantastic stuff, how do you secure it? How do you get access to it? How do you audit what's going on and generally make the environment secure? In the AWS environment, we have the IAM to control access to the Azure environment and the directory service, which is a Samba-like thing to enable workstations and servers to be domain joined. The equivalent in Azure is AAD, which is Azure Active Directory. You know, the easiest way to think of that, on-premise, your workstation servers are joined to your on-premise Active Directory. That controls logons and groups and security and so on. The equivalent in the cloud is Azure Active Directory. And typically you would link the two of those together. Any organization that's using Office 365 already has one of these. A lot of organizations that use 365 don't know it because it's often hidden behind the scenes, but it's there and ready to go. So Azure Active Directory provides all that functionality, and we'll look at that. There's a few other bits and pieces that go along with that. There's a whole bunch, at last count, something like 2,500 third-party SaaS applications, ServiceNow and Dropbox and Citrix and Amazon itself and Google and 2,496 others that are integrated natively with Azure AD, and it's literally 5 clicks to do the federation. Azure Active Directory also provides a whole bunch of value-added services. Multi-factor authentication, controlling access from certain devices, machine learning-based audit logs that will do things like, you know, if I log in Melbourne and log in Singapore 4 hours later, there's probably something wrong. You know, that will detect the fact that your machine is a botnet because, you know, our antivirus labs have seen your machine's a botnet, even though this is a work-from-home machine and you don't have a corporate antivirus on it. So those sort of machine learning-based reports and analytics are available in Azure AD, which then extend to any service that's being authenticated by Azure AD. On the auditing and accountability side of things, AWS has CloudTrail, which pretty much records everything that's going on. In Azure, the equivalent to CloudTrail is the operations logs. But there's a couple of other logs. So the operations logs in Azure handle all the CRUD operations. You know, I create a VM, I start, stop a VM, I delete storage, I change permissions. So any form of metadata change to the environment is in the operations logs. At the service level, most of the services, SQL Azure databases, websites, and so on, have their own logs. Simply because the logs for those are so specific that they need to be, you know, a web server log looks very different to a database log, and so on. And at the lowest level, when I get inside a virtual machine, the way you audit a virtual machine is just the same as on-prem. You're using event log or you're using syslog or so on, and whatever tools you're using on-premise to capture that, you know, whether it's SCOM or something else, work the same in the cloud. And you may have a separate instance of the cloud, you may have an on-prem environment sucking down event logs, whatever's required. But your choice in how it works. And there's a whole bunch of things you can do with the tools. On the key management side, it's key management in AWS. Azure Key Vault is the same sort of thing. It's a cloud-based HSM system. So programmatically, you can create and store the keys, use it to encrypt your own data and so on as a developer. And the various services in Azure are now starting to leverage Key Vault to do things like encryption at rest and so on. And something that's about to hit preview is the ability to use BitLocker, to native BitLocker in Azure to encrypt your virtual machines at rest, and the keys for BitLocker will be stored in Key Vault. And that's, I think, in the next, I can't say, I'm not sure exactly, but very shortly that will hit preview and be available to play with. So what does some of that stuff look like? Okay. Active Directory. Now I've got a whole bunch of them. Most organisations will only have one Azure AD and maybe one for dev. So the main one I'm using here is this AEC management one. It has a bunch of users in it. Those users can come from 3 locations. This particular Azure AD I'm using for Office 365 as well, so it's synced up from my on-premise one. So if I go and create a user using users' computers in an on-prem AD, 5 minutes later, whatever the sync engine is, that user will be replicated up here. So any of the users that say from the local Active Directory have been replicated from on-premise. Secondly, users can exist solely in the cloud. You may have contractors or external consultants or something, and you don't want to put them in the on-premise AD, but you still need to give them access to cloud-based resources. They can exist solely in the Azure AD. And you can also have Microsoft accounts or external accounts that have come from other locations that are then a member of your AD. Similarly, you've got a bunch of groups that, once again, can live in the cloud or come from on-premise. Integrating applications is very straightforward. I've got half a dozen here. I think, as I mentioned, there's 2,500 odd in the gallery. 25, 23, pick something. I'll just do it at random. There's one. So whatever a cloud capture is, that will take about 5 seconds. And the equivalent of doing an ADFS federation is now done. I do have to go into the A Cloud Capture portal and make the equivalent change and say that the authenticating directory for you is Azure AD, and you give it the SAML path or the OAuth path of Azure AD. But it's a lot easier than dealing with the traditional ADFS or similar point-to-point connectivity that you had to establish for every single application. I can then establish multi-factor authentication. I won't go through how it's done because we're running low on time. But if I go back to Lucy Brown, I've said Lucy Brown is an important user in the directory. She's replicated from on-premise. And she needs to use multi-factor authentication. I've just enabled Azure MFA. So I need to start up a different browser security context, so I'll start up Chrome. This organisation has their payroll site internet-facing. The payroll site is just a standard IIS server, which has been told the SAML directory for authentication is this Azure AD. So Lucy Brown is going to log on with her on-premise username and her on-premise password. Now, what it should be saying now is, for security reasons, we need to verify what's going on. So we've contacted your second factor device. And with any luck, that was on silent, but it did go off. So MFA is kicked in. It needs to be to verify, cancel, or report fraud. I'll verify that, and hopefully in a couple of seconds I'm seeing some sensitive payroll information. Did that go through? There we go. So adding MFA is literally that simple. And I can MFA applications, whether they're your own applications or third-party ones, that don't have that capability natively. Once again, like Raj just said on the other apps, we could spend all day on Azure AD, and I'm sure there's other sessions later in the week on that. But once I've got my Azure AD set up, how do I use it to control access to Azure itself? Most resources in Azure, I'm looking at a storage account here. If you go into the settings of a storage account or settings of whatever I'm looking at, we'll have a users section down the bottom. And that will have, right now it's going to show me which users, which roles, which groups. When it comes up. There we go. So right now my virtual machine managers, my resource group managers can fiddle with things, and the overall admins can. So I can go and add new people. So someone who can read the storage account. And what it's going to list now is all those users and groups from that Active Directory. So if I scroll down somewhere, we should see Lucy Brown. Okay. Once again, synced. So Lucy Brown or new starter to your organization, you create them in on-premise AD as you would normally, put them in a Azure admins group, and that's all you need to do. That user's replicated to Azure AD, the group's replicated to Azure AD, they inherit the permissions, when they leave the organization or they change their password, or you take them out of the group, the permissions flow through and it's automatically disabled. So much like the way you control on-premise resources, it just extends to the cloud. The second part was the auditing side of things. So AWS has CloudTrail, Azure has the operations logs. So under management services here, operations logs will record all those create, update, delete type operations. So that virtual machine, Ignite 123, I created 15 minutes ago, the deployment for that is recorded here. If I drill into one of these and look at the details, there's a whole bunch of JSON or XML which will tell me IP addresses and who they did it, what time they did it, did it succeed, and so on. So it's in a format that can be downloaded to your SEIM tools and analysed and read by machines. I can download those logs manually, I can pull them via PowerShell, I can export them, there's a whole bunch of different ways I can deal with those logs. But those are the logs specifically for the metadata type changes on Azure. And then each of the individual services, so if I go and pick something like, I don't know, an Azure web app, which is a website, and trundle down here, when it comes up, there'll be a whole bunch of diagnostics and logs and so on that I can configure for each of these. So each service has its own logs as well. Okay, Roger.
Hey, so we are running out of the time. Sorry guys, we are rushing you. So management aspects of it. You have what is called the resource metrics utilization. We have something called CloudWatch. On Azure side, we have dashboards and monitoring. So just now Andrew was browsing through, that is what is called includes the dashboard and monitoring. Any resource like virtual machine, cloud, what is called the web app or database, anything that you look at it, we provide a bunch of what is called the monitoring and dashboard tools, how it is being utilized. What is called the plus point for us is if you are familiar with the SCOM, you can even use Azure to be managed by SCOM, and then it is a hybrid deployment that you can think of as well. And CloudFormation is the template-driven infrastructure deployment. When it comes to Azure, we have something called Azure Resource Manager. How many of you are familiar with ARM or Azure Resource Manager? 1, 2, 3, very few. So maybe I'll see that depending on the time, I'll show you how to run what is called the ARM templates or what is called the quick start templates and then deploy a bunch of resources on Azure. Plus is a native integration. In order to build those templates, it's a kind of drag and drop in Visual Studio. So we have a native integration there, and what is called the portal GUI is getting ready soon as well. Trusted Advisor is the tool that Amazon uses to tell you that you have 10 virtual machines, XYZ size, you are not using them what is called well, you can downsize it, you get certain amount of savings. So that is the what is called the billing and resource optimization. On Microsoft side, we have announced something called Resource Health. You see a tiny asterisk, that means that the service is in the preview. And we have a tool called Operational Insights. I'm not sure how many of you recall during the keynote today, Operational Insights was shown. I'll see if I can very briefly show you as well. Operational Insights is basically what is called the cloud-based software as service. You install a tiny agent on your virtual machine. It pumps all kind of information that you are looking for to the cloud, and then nice dashboards are available for you to straight away consume. If you have a system center on-prem, it can connect to system center, pull the information as well, and present your Azure resources, system center on-prem resources, both together in a single pane of glass for you to manage. Okay, so Resource Health is in preview, hybrid cloud, single pane of glass, as I said earlier. So that's a plus point when it comes to. So very quick one, monitoring and infrastructure deployment. Let me see, we may need to skip that one. So what is called the OMS, let me touch the OMS before we go further. So this is the OMS dashboard. For example, we have something called Solutions Gallery here. You can go ahead and then, if you are familiar with the management packs in your on-prem SCOM, so these are the management packs, for example. You can go and add your what is called the components into your package, and then you deploy a tiny agent, as I said. It can go through, depending on the component services that machine is running, it can give you different insights. For example, Active Directory, specific counters and issues, and what is called the monitoring aspects of Active Directory, SQL Server, how much IOPS, how much RAM consumption, how many transactions are issued, how many locks are there, etc., etc., etc. So that detail it is. And if I go back to my dashboard, you can look at like malware assessment, backup is taking place or not, how many changes are happening. There are high priority recommendations are there for Active Directory. You can drill down and see in detail. So this is not set up by you from scratch. All you need to do is install an agent on your virtual machine, add whatever you wanted to see from the gallery, everything is up and running. Okay, it is a software as service kind of portal that is there that you can consume from the scratch. So that is the operations management. Next is the infrastructure deployment. For example, if you notice here, I have built this template. All you need to do is go into my Solution Explorer, look at my templates. You see on the left-hand side, you have something called JSON outline. So you have multiple, what is called the parameters, values. Similarly, you have resources. I can simply say right-click, add a new resource. So what I'm doing now is I want 100 different virtual machines or 10 different virtual machines with the various components to be available for my developers. And then is a DevOps cycle. Multiple times they want to deploy for various things. So from here, you can choose what components you want from the cloud and then add that to the template and define your parameters. Everything is ready for you to start deploying. So once that is done, I can go here, say deploy, and then I want to deploy brand new deployment. I want to see here, once I log into the Azure, all from my development tool. I can put in my credentials, all my subscriptions are pulled from the cloud. All I need is I want a new resource group. I'm going to call this as Ignite. And then resource group location, where am I going to deploy this? Let me deploy to ESTS2. So what it does is it created this resource group, and then if you look at the edit parameters, whatever I specified as a parameter, I can go and change this at any time. So I build this template, pass it to the developer. Developer puts in the Azure portal this JSON code. He puts in the Azure portal, all the parameters are asked as a question. He fills them up, is deployed. So this is done. One SQL server, one web server size, SQL server size, etc. I simply say deploy. It starts deploying it. So if I switch to Azure portal right now, if I go to my resource groups, I choose only the test subscription, that's where I deployed. So Ignite ARM is a resource group that I used. So if you go in here, you can see that the components are coming in. So in a short while, let me see if there are any errors. How is it going? So it's deploying, or for some reason it has failed. Okay, let me look at that shortly. So but the other way, if I look at the one that is already deployed. So if you notice here, I have two virtual machines. I have two network interface cards and a security group that Andrew spoke about earlier, and then the public IP attached to one of the virtual machine and the virtual network, etc., etc. So all of them are being deployed as a group. So that if I simply go ahead and then say that resource group delete, everything is gone. So if I want to deploy this any other region for any other purposes, you can go ahead and then deploy it. So that is the what is called the managed deployment on the cloud. Any questions so far? Last, so what is called the last section.
So we're at time, so we'll wrap up there for any questions. So the goal of today was just to give you an overview of the breadth of services and how they compare. You know, we've covered about 10 services out of 100 or 200, depending on how you count them. And there's sessions for the rest of the week that go into a lot of these in a lot more detail. The key things to understand is storage, networking, the virtual machines, because that's really where a lot of things start. Azure AD and the identity side of things, and then the data and the databases are the next most common thing that comes after that. So,
any questions?
Any questions?
And as we said that the slides will be uploaded, so feel free to consume them. And then each and every part of the Azure services in the Azure documentation, multiple videos are there. If you are interested to pick up any one of them and start learning, watch this and pick it up. We have some T-shirts. If you can grab it, that will be great. Thank you. Thanks a lot.